right, welcome to Physics Lesson 1, Part 2. This is the second part of our Forces in Motion lesson, the motion part of that lesson. Eva, take it away.
All right, so what is motion? Motion is when an object is changing its position over time. So it's basically just when an object is moving.
Well said. Now, one of the key things to understanding motion is Newton's laws of motion. As you can see from our slide, there are in fact 3 of them, and he did create 3 laws of motion, and we're going to talk about them. Okay. Now let's get to the first one. An object will remain at rest unless acted upon by an unbalanced force, and also an object will remain in motion unless acted upon by an unbalanced force. Essentially what this law says is that an object in its motion, either sitting still and not moving or in motion in any particular direction, will remain unchanged and not be affected unless a force acts upon it in an unbalanced way. What that means is that if there are 2 opposite but equal forces, the motion will stay the same. But if one force is stronger than the other, or there is just no opposite force, the motion of the object will change.
Very good. Okay, so Newton's second law of motion states that the acceleration of an object is directly related to the net force and inversely related to its mass. So it sounds kind of confusing, but it's really not. The acceleration of an object depends on 2 things, force and mass, and the equation for it is just force is equal to mass times acceleration. So here's a pretty good visual of Newton's second law of motion in action. So in the first picture on the screen, there's 1 person in the cart. In the second picture, there are 4 people. And because 4 people weigh more than the 1 person, the individual pulling the cart has to apply more force when pulling the 4 people to get to the same acceleration as when pulling the 1 person. And another example of this is just like if you push a small car in a truck with the same amount of force, the car will move faster because it weighs less than the truck.
Yes, and now we are on to Newton's third law, probably the simplest one. Every action has an equal and opposite reaction. So in our example on the screen, there is a man, well, a stick figure who appears to be rowing a boat. And how this would work is essentially the oars would have an opposite reaction that propels the man forward and the canoe or boat forward. However, I think a better example is this little guy up behind me, this bird. If he were to fly, he'd be flapping his little wings. And when he flaps his wings downward, that creates an equal and opposite reaction due to air resistance, and he shoots upwards. So yeah, that is how the third law works.
Okay,
And that is it for our motion presentation.